Converge or diverge, sigma where n goes from 1 to infinity, parentheses, nth root of 2 minus 1. Well, what can we do? First, as usual, the nth root of something, we can look at that as a power. This is the same as saying sigma where n goes from 1 to infinity, nth root of 2 is the same as 2 to the 1 over nth power. Right? Just the usual business in calculus. Almost always look at the root as a power. And then we have the minus 1 after that. So we are making some progress, but now what? Perhaps we can do some tests for divergence, and we will just do that in our head. This is the an. If n is approaching infinity, we will have 1 over infinity, which is 0. 2 to the 0th power is 1. 1 minus 1 is 0. Unfortunately, test for divergence doesn't work because we do end up with 0. So now what? Well, after we change the nth root to 1 over n power, this is kind of suspicious because if you look at sigma, n goes from 1 to infinity, 1 over n. That's the harmonic series, and that diverges, right? So maybe I can do some comparison with this. And I would like to use the limit comparison test for that to see if we can draw any conclusion. And I wanted to tell you, if you want to use the direct comparison test, unfortunately, in this case, it wouldn't work. Limit comparison test is the way to go. But I'm just going to try it and convince you that it will work. So let's put down the things that we know, which is just the 1 over n. Just put down sigma when n goes from 1 to infinity, 1 over n. We know this is the harmonic series, so I will indicate that right here for you guys. Harmonic series, and we know it diverges. Okay, and now we will check the limit. We check as n goes to infinity. And let me just put this on the top, and we'll use this expression for now. 2 to the 1 over n minus 1, and then we divide it by the things that we know, which is the 1 over n. All right, here we have a small trouble. When n is approaching infinity, 2 to the 1 over n, 1 over infinity is 0. 2 to the 0 is 1. 1 minus 1 is 0 on the top. Infinity here, we get 1 over infinity, which is 0. This is a 0 over 0 situation, so we have to do more work. And the work that we'll do is use L'Hopital's rule. So I'm going to change this right here in terms of x, as x approaching to infinity. So I can be legitimate and take derivatives. As x is approaching to infinity, let's look at 2 to the 1 over x minus 1 over 1 over x. And we will just take the derivative on the top and then the derivative on the bottom to see what we get. So if we do that, this is going to be, put on arrow, it's approaching because we're talking about limits. How can we take the derivative of 2 to something? I'll write this down right here for you guys. So recall that derivative of, let's say you have a base b to the x power, okay? This right here is the same as we maintain the exponential form, which is b to the x, but then we multiply by ln of whichever this value is, lnb. Okay, so this is the derivative formula that we are going to use. Anyways, 2 to the something, it first states the same as 2 to that thing. And by this first, we first multiply by ln2. Okay? Once again, 2 to the something, it stays, but then this is a 2, it's not e. So we multiply by ln2. If it's an e, then we didn't have this. Okay? But then, by the chain rule, we multiply by the derivative of that. And the derivative of 1 over x is negative 1 over x squared. Okay? And then we are going to divide it by the derivative of 1 over x. And once again, the derivative of 1 over x is negative 1 over x squared. And you see that this and that cancel each other out completely. And let me erase this right here. Well, what do we end up with? This is going to be approaching to, as x is approaching to infinity, we have 2 to the 1 over infinity times Ln2. And then once again, this is 0. 2 to the 0's power is just 1. So all this is pretty much approaching to just Ln2. And this is the limit. Okay, this right here is approaching to Ln2. And the way that we did that was by using L'Hopital's rule. And then we have to do it, but then we change that to x first. Okay? Whew. And now, is this useful? Ln2 is about 0.693 something. But then for the limit comparison test, as long as this number is greater than 0, it is useful. And we will have the same conclusion, right? This right here diverges. That right there will also diverges. Same conclusion. So at the end, let's write it down here. Here is the conclusion. The original, let me just write it down. Sigma when n goes from 1 to infinity, nth root of 2 minus 1 also diverges. And the way that we did that was by the limit comparison test with the things that we know. Okay, so this is what we have. That's all.
That's it.
Just using some of the clock. And he fires. Yes!